Hi everyone. Today we'll look at object-oriented programming. Um, there are three ways of viewing the programming paradigms. The first way is a flat coding. This was the paradigm used till I think uh, mid 1900, I think 1970, 1980. That is a single sequence of logics, and I believe since mid 1970 till the object-oriented paradigm was introduced, which is 1985, I think, about 10 years or even longer. Functional coding was uh, uh, the basic the coding ways. What it does is that it defines functions like a module, and a module is defined once and can be invoked multiple times. So that is a functional coding. And since 1985, object orientation was first introduced, but not really actively used. Uh, the first object-oriented the programming language was introduced was in Java. In the case of Java programming language, Java is it's kind of object-oriented programming language. Java was first introduced in 1995 by Sun Microsystems. Um, so since 1995, object-oriented coding becomes uh, recognized, and it was really, really good way of programming. Everybody understand uh, only since only 2000, the year 2000. So, so object-oriented coding is so like defining classes, uh, and then functions are created and associated with a class. So a class can uh, consist of static fields and behavioral methods. So fields and methods both are associated with a class. Once a class is defined, then multiple objects can be constructed based upon class. So you can think of the class is nothing but a blueprint. The real implementation based upon blueprint could be multiple, right? So many different ways that we can construct if we have a blueprint. So blueprint is kind of defining a class, and an object or instantiation of objects is kind of implementation of a blueprint, which is called the class. Um, let's say this is a camera lens. Of course, each individual camera lens, this is an object, a specific object. Okay, even this is the same models, but actual, the physical, the lens that can be an object. So for one model could be multiple different real physical objects available. Let's say we could think of create a like a blueprint to one model and therefore multiple of those, or we could have a collection of all of this lens, camera lens, as a class, and then we can say, hey, this is one specific object, another object, and another object. We could think that way. it's up to our um, the implementation, our um, uh, the way that we want to make digital systems may be determined by um, our need. Okay, if we think uh, to have, uh, if any camera lens is a lens, then the lens can be instantiated based upon one template of lens. We could think that way, or we can say, hey, this is a mirrorless lens, and the other maybe different kinds of lens. Then we can make, hey, I want to make a class for these kinds of lens, another class for another kinds of lens. We could think that way also. So all possible, but the programmer or designer need to decide, right? If if we are working on the um, lens manufacturer company, then we definitely say, hey, this is one class. We have a multiple other objects, and another class, and another class, and another class. We could do that a little more specific. Classes can be defined. Or if we say, hey, I'm running a retail store like Best Buy, so we have a lens, there's one class. We have a TV sets, there is another class. We have a computer Windows system, there is another class. Mac, Apple products, another class. Hey, we have a dryer, we have a washer, all different kinds. It's a little bit higher level of the products. If you want to make digitalize it, then the class definitions may be defined. This as a whole, we can say that is a lens. Okay. Anyway, suppose this is what we want to do as a whole collection. We want to define a class. Then we say class lens. Then lens can be constituted based upon focus lens and aperture type of things, right? This is like a blueprint. Based upon this blueprint, and we can say one lens that the focus lens is a variable 1 to 105, and aperture that is also range of aperture. The other object may be constructed with the focus lens is fixed focus length, which is 55, and aperture that is in the range 1.4 to 8. The other one may be zoom and so on and so forth. So many different ways that we can do. So we have a multiple instantiation based upon a definition. So this definition is called a class. Okay, class is a reserved word, and then followed by real class name. We call it lens. The actual coding is this. If you define lens, then you need to define some of static fields. If the lens can consist of focus length and aperture, then when we construct a specific lens, let's say my lens, if I have 10 lens, then I can say, oh, this is a lens 1. So my lens 1, then focus is something, right? So I want to, as I construct an object based upon this blueprint, then there is some method that can help me to construct my lens. The way that I can construct my lens, I need to have two values. Value for focus, another value for aperture. Therefore, having those two things, then I can say, hey, my focus is this. That is added. Hey, my aperture is this aperture. that is codified in this way. Self.focus. This particular object, the focus of this lens is whatever the value that I used to construct my object. I would say 55 or 105. An aperture, 1.4, 1.8, or 2.0. That is my aperture. And having this focus and aperture values, I can construct my objects. Okay. Not only this static aspects, but also there is some functions, some behavioral aspects may be needed. I may need to define, like as I defined here, this is a underscore and underscore, it's a double underscore, init, underscore and underscore, open, like the function definition. So this is exactly the signature of a function definition, right? DEF followed by function name, open, and the parameters, list of parameters. This is a special function name, function that we can define our own function in addition to some functions already defined. In this case, it is not already defined, but it is reserved. Having this underscore underscore and function name ending with again double underscores, then this kind of function is called magic function. You may see why it is a magic. Usually, if it is a function, regular function, then we need to call that function. The way that we invoke the function, then we need to use that function name, right? For example, this is a function by. Then I need to, when I call this function by, then I need to call by, and then I send the arguments, right? I want you to recall the functions, the modules that we learned, right? But if this is a magic function, then we don't need to. I'll get to the points with the real example. But anyway, this init magic function is the function already reserved. That function is activated when an object is constructed. And when an object is constructed, then we need to have focus value and aperture values. Focus and aperture values. Two arguments are needed. By the way, we have self here. This is a reserved word. In the function definition that we learned so far, self is not needed, right? But when we have here object-oriented programming, then the function parameter should start with the self. Here we have self, and another self here, and another self. Self is also a special word. Self means that is an object identifier of a specific object. If I construct now a new object, then that ID of that new object, we should not remember the ID of that currently that I am constructing, right? We do not assign ID. ID is automatically generated. And we do not know that ID. But we know some variable called self. If we say self of a specific object, then that is an ID. Look at here. Self.focus equal focus. Then focus right-hand side is coming from this parameter. Left-hand side, this is my variable. Okay? This is not just the focus, but it is specific focus. Specific focus of specific objects. So we call that self.focus. This aperture is not just aperture like something that we received from the function called aperture value. That aperture value is right hand side, so that should be assigned to left hand side, which is my aperture, self.aperture. So by activating this init function, then I would have, hey, I have a focus and I have my aperture. I have my focus length, I have my aperture values. Having those two values, now I can say, hey, this is my object. Object is constructed. Okay? That's what I have here. When I send lens, this, in order to instantiate, in order to construct an object, then we simply, rather than call this init underscore underscore init underscore underscore, we simply use this class name. Class name, open and close parenthesis, and then this argument is corresponding to the parameter in this function definition, this magic function definitions. Second parameter in this magic function is the first argument. And then second parameter defined in this magic function could be the second arguments when this lens is constructed. Having this, when I do this, class name, and then like a function with the arguments, then this is activated, an object is constructed, and that object is called lens1. So that I can hold that object, right? Remember that the first class of this semester, I said the assignment, then right hand side, this language here, lens open and close, then this construct an object. That object is held by this value. We call this variable. So this variable is nothing but label. So that label holds that object. So whenever I need to look at that object, then I need to see, hey, lens1. Then that points to the specific object that I created right now, right? Second one here, the another lens with another arguments. Then coming here, these two values assigned to focus and aperture. So object is constructed, and that constructed object is held by this label. We call this is the object variable, right? And another object variable. This is a definition, right? We define. If we have not only the static aspects, but also behavioral, then we need to add this. Okay, this def function name, open, and one parameter, owner. Then we always start with the self comma, right? And in this case, display, then open and close parenthesis with no parameter. Even so, because this function is defined under this class definition, then we need to say, hey, this display can, when you say display what? Display myself, here, self. So we need to have self. Okay, so class can be defined over static fields together with the behavioral methods. We call that method. Method can be a function, but like a function that we learned. But when it is defined under a class, we call that more specifically methods. And then we see the difference. If it is a method, then first parameter, always self. If there is no parameter, still we need to have self. So when I call this function, we only consider one value for owner. So one argument is needed, although we have two parameters here in the definition. But when you called, only forget about the first self, but start with the second ones. Like here, lens, when I invoke this, I don't need to worry about this, but this self is needed only when you have here self. Remember that here? Self. That is the self of that. That self is needed here. And then parameters is needed on the right hand side. And yeah, two parameters needs to be received. Therefore, two arguments is shipped out to these definitions. So put them together, then class can be defined. Class, lens, colon, and then the first definition is nothing but the magic function, underscore, underscore, init, underscore, underscore, self-focus aperture. So right hand side of this is nothing but the value that we received here in a parameter. So that can be assigned to the left hand side. Then left hand side focus is not just a focus, but self.focus. So focus of these objects, that's what it is. Self.aperture, what that means is the aperture of these objects. So this init function can be used when an object is constructed. We have two more. Now this buy and display. Buy and display is behavioral. One argument is needed, owner. Therefore, two parameters, self, comma, owner. Owner can be assigned to self.owner. Display, no argument is needed. When I want to display whatever, then I want to display this. Print. See here, we have a placeholder. Something owns a lens of a focus length, colon, something, semicolon, aperture, colon, some others. Close that double quotes, dot format, so that we have three placeholders, right? Those three placeholders needs to be filled by the values in that format functions. Self.owner needs to be filled here. Self.focus needs to be filled there, and self.aperture needs to be filled here. So it could be, for example, John owns a lens of focus length 105, aperture 2.8, something like that. Okay. So having this, based upon this class definition, then we can say, we can construct an object. So first constructor here, lens, open and close parenthesis. Lens is nothing but the class name lens, then it doesn't look for function name here, but look for init magic functions. So there is an init magic functions, and then two parameter, two values needed. So two value sent. Then this object, lens 1's focus is whatever the focus we sent, 1-105. Lens 1's aperture is 4 to 8, right? So, so for example, lens 1, this is an object, and these methods now can be invoked by an object, because these objects are, these functions are defined for this class. No other can invoke this. Only objects that is constructed based upon this class can see the function here. No others can see this. Only the objects. If my objects comes from this lens, then I can see this. right? Only, for example, you guys graduate from Mercy University, then let's say Mercy University has some something, then only you guys can see that things. No one can see that things, right? If your lens 1 is constructed based upon this lens class, therefore I can invoke the method. Those methods are associated the class that I am from. Because I am from that class, I can see it. I can call it. I can invoke it. So if I want to see lens 1, so the way that we invoke, we need to use dot notation. Dot, lens 1 dot, and then display. If I say this, then then I can, this is display function, right? Display function is activated. But this display function knows self. What is a self? Self is ID of these objects, not owner of or focus of aperture of any other, but only the one that I know, which is a self, my focus, right? Before I do this, I need to say lens 1 dot by and if I say John, when I say lens 1 dot by John, then lens 1 is qualified to invoke this. And then by needs 2 parameters, which means only one value for owner. So owner John comes here. So this owner is nothing but this right hand side owner. So owner John is assigned to self.owner. So whose owner? Lens 1's owner is John, right? Self.owner equals John. So self means lens 1. Lens 1's owner is John. I invoke this, and after that, if I invoke display, then the first placeholder here, self.owner. What is self.owner? Self is nothing but lens 1. What is the lens 1.owner? Lens 1.owner is John. So John will be filling this blanks. So John owns a lens of focus length. What is focus length? Focus length is, this is focus length, right? Because lens 1 is that lens 1. 1-105. That already assigned here, because this is nothing but here, that focus, and that is right hand side of this, assigned to self.focus. In this case, lens.focus. So lens.focus comes here, which is 1-105. Same thing, aperture. Aperture is assigned here, aperture 4 through 8, which is this aperture. That is the right hand side of this second statements. Then right hand side is assigned to left hand side, which is the self.aperture. Self means lens 1. So lens 1 dot aperture is 4 to 8. So lens 1 dot aperture is 4 to 1 over there. So when I display in self, then lens 1 here, the object, that object can be the self here. So self is nothing but that color, lens 1, object ID. I already explained that if this is a method, then when I construct lens 1, then lens 1 is the object, so that I can buy it, and then I can do the display also. So actually the method can be invoked in this way: object dot and function and argument, whatever arguments that needed. In this case, 1 arguments. In this case, no arguments, right? So displays, when I do this display, then I already explained that, right? So function codings now moved to object-oriented codings. So what could be a class? We need to start with the multiple objects. If we can group those objects, if we are represented in a same templates, then we call all of each one of those objects in that class. For example, if object has first name, last name, major, the university name, and advisor name, and courses to take. If some object is constructed based upon those values, then we can call that object a student, right? So in programming, we first define students with those field names, and then we need to construct each object. Each objects that look like students can be constructed based upon the student class. Class can be represented like this. And the function also, you can define this kind of functions. So class has variables and methods. Okay. So class is variables, those variables, then we can say that those variables can be when a specific object is constructed based upon section class, then we need to have those 3 values. Having those 3 values, then we can construct. So my object has students, my object has instructor, my object has a title. And then section may have gradings. This grading, if I have a number, then I can tell you letter grade. If that number is greater than 93, then I can say, hey, your letter grade is A. This kind of branch statements that we learned, right? Already. And finally, we can return. Only difference here is that the function parameter always start with the self. So this self needed to invoke this grading function. This self is needed to access variables. When I see these variables, then I need this self.student, self.instructor, self.title. When I call this grading function, not simply grading open and close parentheses, but we need to say some objects like self.grading or specific object. If we define that object, then that object dot grading. So object is created like this. Section. Let's say this is a student IDs. Students is in dictionaries. Okay. So section first field is student, which is in dictionary format. So we need to say students equals, this whole thing can come here. And the second parameter, this is student first parameter. I mean, first arguments. And second argument is instructor. Instructor is shown. Literally, that string is hard-coded string is sent. And the title also hard-coded. Python is sent there. Okay. When I access any specific field here, then I can say that class student is an object. This is an object, particular object. This is an object. Like object ID. Real object ID is not feasible, but that real object ID can be labeled by this class student in our coding. So we simply easily use that ID. So class student, this is nothing but that ID, like self. So self.instructor. So self.instructor can be accessed by this self.instructor. Like here, self.title. Okay, so without doing further, we will look at notebook in Google Colab. Consider three classes: student, class, the real class, or you can say course, and faculty. And there are multiple fields, static fields: name, age, enroll, therefore students. Class, title, CRN number, taught by, so that's class. And name, rank, salary, therefore that is a faculty. Those are static aspects. And also behavioral aspects. So eligible alcohol for students, or calc GPA, that is for students. And calc tax for faculty, there is another behavioral aspects, like methods, or evaluation of a performance, that is another behavioral aspect for faculty class. We call that methods. So you can define class like this. Based upon class definition of each, we need to define an object. This is one small object, another object, and another object. The objects are defined. They can be related. If it is enrolled, then the students can be enrolled in a specific class. Okay. Value of this enroll, you can say, you can assign, for example, CISC 131, or literally like a string within double quote, or you can create an object first here, like a class. Title is Foundations of Computing 1, CRN number, whatever the number, taught by Dr. Yoon. So that is constructed, and we hold that object ID. And that object ID can be assigned to this enroll value. Therefore, this guy is now linked with this class objects. There is a physical linkages, physical connections. So when I say, oh, what is the class that I in? What is the instructor? Instructor's salary that I am enrolled in, then I know who. So enroll, and it says enroll according to this, knows a specific class, either this or that, and then the instructor, then within that objects, then we know taught by. Remember that only an objects related to this class can see this. Not the objects of students can see this. Any object's ID that is created based upon this class can see the instructor. Because I already assigned the object that was created based upon this class. Therefore, that value, that object ID can see who is teaching. This who is teaching is not just the value John Yoon, but object ID that is constructed by class. That ID is assigned to this. But that ID can see all of this, salary, even salary. Student cannot see my salary. But along that path, because there is an object, this object is assigned to another field in another object. That is assigned here also. Therefore, we traverse that path expression, jump from one object to another object, and another object, and eventually can see the salary, right? Therefore, in Java, for example, Java is a more formal object-oriented programming languages. So in Java, we can say, hey, you want to show salary is protected or public? Is it going to be private or public? Like safety issues are completely implemented already. Therefore, we can use it. But in Python, there's no such things. Python's object orientation is much simpler than real formal object-oriented programming languages. But if we don't care about securities or privacies, safetyness, then we can simply use it, right? So that is Python. Python is the language that we can use easily. If it is a very rigid programming language, of course, then we have to consider so many different things. Therefore, coding looks much more complicated. But the language that we are learning right now, simple, easy. So enjoy. All right. Having that understanding, so each of object class sections can be defined over set of its students and the instructor and class title. For example, an object IASP 505 DFA has the student set, for example, Adams, Sam, Peter, Chris. Those four students are the students that are interested in this specific course. And course title is Python, instructor John Yoon. We simply say that, and then what is a student? Students is all of those. Title, we already know that is Python. Instructor, John. So we can say John teaches class IASP 505 DFA to the instructors, those to the students, all of those. So if we run it, then we can see those three print statements, and finally that the statements. So John teaches the class Python to students, those students. This is the typical the language that we have learned so far. Now let's see object orientations. Okay, so this photos that you already looked at. Okay, now we need to define students, class students. So class students, colon, static aspects. Remember, this is magic functions. So somewhere here I explained that magic functions. Where is it? This I explained the self. Here are magic methods. a so-called Python's dunder. In other words, a double underscores method. This is not single underscore, double. Underscore, underscore, init, underscore, underscore, and self. We call that Python's dunder, or double underscored method. Or sometimes we call that magic methods, or special methods. Why they are magic, why they are special, why they are called double scored or dunder. Because this is pretty much already designated name. This is an initializer, init. str, then there is a designed for string representation. str underscore underscore str underscore underscore means I want to present strings. Okay. Back up here. So that is init. Init. When I construct an object, I need 3 parameters: name, majors, course. So name is assigned to my name, major is assigned to my major, and CRS assigned to my course. So self means first parameter is me, my ID. So we can construct this. So this is constructed. So this is constructed. Now we have we can think of behavioral. Okay. So what behavior that we can consider in so by the way, back up here. What we need here in object orientation, we need to first, step 1, define a class. Step 2, constructing an object. Not only one object, constructing one object at a time. So object 1, object 2, object 3, object 3. We need to construct based upon class definitions. And then we need to access. Static elements can be accessed, which is a variable or a field. Or dynamic elements can be also accessed. We call that invocation, right? So those are the steps. So first here, calc GPA, that GPA function already given here. So we need to do behavioral aspects of object in students, behavior students, add more class. Let's say if we want to add more class, then we need to do diff and add, right? And then also calculate the GPA based on class grades. And then we need to do this. For this add, then we need to do, here we have self. So self, we have course here, course. Right now, let's assume course is a here CRS is a let's assume that is CRS in a list. If it is the case, then we can add. Remember that students can register more than one class, right? So it is very natural to be in a class, in a list. If it is a list, then we can append whatever given those. And calculation GPA, if we have multiple grades, but grades in remember that double 2-star parameter, 2 stars parameter, which means that is parameter in a dictionary, right? So that is calculation GPA is given here because grades is, let me copy of this. So copy of that here. I need to put this back there. Okay. So that is good. So grades is a dictionary. Therefore, we want to consider keys first. So what happens here is the grades for particular students, then we can consider in this way. For example, let's say make another. Let me create an object, construct an object. If I want to construct an object, then we definitely invoke this init magic function. Instead of using this magic function, we use class name students, but all others remains the same. So we need to have a name, major, and CRS. So name, we can say Sam, and major, CS, and then we can say, oh, this is good ones. So we can say here, the Python is A, Java is A, English B. Let's say Sam owns that one. Okay. So we construct. Let's say I execute this. If there is no error, then I can definitely construct an object of this. This is an object. I cannot use this, right? This is like a complicated ID. Therefore, I want to have my own readable ID. We can say student Sam equals that. Okay, then I can easily see what is this student Sam, let's say, and name. Okay, then I can simply see this is ID, right? What is this guy? Sam's name. Sam's name is Sam, right? That's what it is. So I can access the values here, whatever the major. If I want to see major, then I can say also major. What is the major of Sam? Then I can that, right? CS. Of course, I know that, right? Having this, I want to add more so that I can say add, and then if I do this, print Sam's of that, I think I have an issue here. Course is not a list, right? Course is a dictionary. So I need to change here. This is not a list, but a dictionary. If it is a dictionary, then the adding new ones is not like this. We need to have, say, course dot update. Then we need to have here not only that value, we need to put some other ones, or you can say just empty, right? Or you can, I can say, see here. Let's make it, no. Sorry, we need to do CRS. You simply update that CRS. But when I call this here, rather than this, I need to put that the dictionary formats so that I can have C. Okay. So when I call this, what happens? Dict object has no attribute append. Of course, where is append? Oh, I need to, because I changed this, but I need to redefine this. Previously it was a list, right? I need to redefine this, and then I invoke this, then it shows. Because originally when this StudSam was constructed, 3 courses there. So I add one more, CIS 131 and C, then I have this, right? Not only that, because StudSam was constructed on the student, it can calculate the GPA. So I can calculate GPA. StudSam.calc, calc GPA. Calc GPA needs this guy needs a grade, okay? So grade, whose grade? StudSams.course. That is needed. It says two primary dictionary format of those needed, but course is in the dictionary format. So having this dictionary format like this, if we see this code, we need to first consider the keys. Python, Java, English, CIS 131, that is the keys, right? So looking at those keys and the length, so how many keys? Remember that GPA? We need to get, for example, if it is an A, we need to convert that to a number. So A is nothing but 4.25, A minus 40, and then B plus 3.67, and something like this. This may not be the case at Mercer University, but let's say this is the rule. A is nothing but 425, A minus is nothing but 4.0, B plus is nothing but 3.67, and so on and so forth. That is our scales, right? Some other universities has only A, B, C, D. So A is 4.0, B is 3.0, C is 2.0, something like that. But ours is a little bit more complicated. But anyway, we converted that to a number, and then having those all the numbers, add, and then finally we need to divide that to the number of the classes. So in order to get the number of a class, then I need to get the length of these keys. Remember that, because this is a parameter, right? That parameter is nothing but this is StudSams.course. This is StudSams.course is this things, pairs of the course title and letter grade, course title and letter grade for specific object ID whose name is Sam, whose major is CS. So I want to calculate what is Sam's GPA. Then I need to send Sam's course record. So course record, I send it. But because I send the value in a dictionary, then I need to use double star. So when I call this double star of that dictionary, then in the implementation of this definitions function, we still use, we receive that in that 2 stars parameter. Okay, we call that dictionary parameters, so that we can calculate that. So see what happens if I run this. We already, this StudSam knows that the current definition of this class. So we simply run this. Then we saw, oh, his Sam's GPA is 3.53. Things like that, right? If we want to print this in a specific way, so then you can see print Sam's GPA is this dot format, and then we do this. This format needs 2 values. First one is that object ID, right? Which is Sam's dot name. That way we can say Sam's GPA. Sam's GPA is that. And then here, rather than having this long, I can say colon point to F. So I want to see only 2 decimal points. So when I run this, and I can say Sam's GPA is 3.53. Okay, this shows the magic methods. Okay, so one of the magic method here, str. We looked at init function. There's another one that is str. str that's automatically invoked when an object is constructed, and whatever we defined in this function, that is represented. Without this, then some other can be represented. For example, if I have this, if I print StudSam, for example, and run, what do I have? This is it. This is not really readable, right? So we want to see only calling this. If we specify some way here, then it is the way that we can see it. So what I want to do, I want to copy the same as this to next code from here there, right? And then I want to do this string. So I have this, but when I print JP, then I have this. But if I change here, it should return students instead of this, because my implementation is this. So I need to run this first, and then when I run this, it says student, right? So if I show here, then it can be seen here in this print statements. It's like this, right? Previously, if I don't have this and run this and run this again, then I have this. But if I have this and run, then this guy runs students. But this is not logically what we want to do, right? So we want to say, hey, whatever the student's ID is required, then I want to say, oh, this is a good one. Say name is whatever self.name, major is self.major, course is that is everything about me. So that if I define my class like this, and if I construct my object, which is called that JP, and then when I print that object ID, then it specifies whatever that I ask to do here, so that it will be printed like this. Name is John, major is CS, course Python A, Java A, English B, right? So in this way, we already constructed it, but anyway, class is defined and class can be instantiated, which means objects are constructed. So for that students, we can say this is not a good way, right? In our case, we need to have, we can do this because not necessarily dictionary. If we don't use this method add, we may not have an error. Even if we use list only rather than dictionary, watch this, so it should be okay. And then we can consider here a section. Section can be also defined, right? Section has a student ID, instructor, and title. Title of that class sections, and instructor, and then students. So that what happens here, this is a class. Class has the instructor. Class has a student, because the student is enrolled here, like this, enrolled, and he knows what instructor. Only that portion is implemented in our example, but you can maximize that also. So this is the initial. This is the way that we can construct an object of a section, and then we have a grading. Remember the grading that we looked at? Given grade, then I can convert that to letter grade. And then section can be, we have students, so initially, the section of the CISC 131 DL, then Adam 0, Chris 0. Initially, this is the way that we construct, right? So when we first construct a section, then we know the students' names, but there is no grade yet. And instructor John, title Pythons, another section 231 empty, one student enrolled, John is the teacher, and that is a Java, and 525 empty, then Peter, value 89, and David, and database. Let's assume like this, and then we can print these two, the objects. We have no problem having this, right? Because we don't have any definition of underscore stl. If we have underscore stl, then we can display the way that we implement here. But without that, then only object itself is object ID is given. We can improve that a little bit like this. Exact same ones. Okay, if we improve that and similar things here, then only, okay, this CIS 131 says that fine. And students, because this is not known, So student dictionary, that is, let's assume those 4 students are used to construct an object of a specific section called CRS object. Instructor Ethan and title Mobile. We can print that. Then we can still having that. Therefore, see here. These two CIS 131 and CISC 231 MT, look at here, then that these objects are constructed based upon this definition. The definition this does not have str methods. Therefore, when we print object ID itself, then it gives me ugly object ID, right? So that's still give me ugly object ID. But this section is newly right here that is constructed, which means this is a new section. That new section has str method. Therefore, when I call that CRS object, then it gives me detailed of this. Student enrolled in Mobile taught by Ethan, right? That's what it is. If I, here, CISC 131 DL, if I redefine this new object, this is an object, but object is revised. Same object here, but revised by current section. Therefore, when I see here print CISC 131 DL, then it clearly tell me the presentation, the way that we defined in that underscore str magic functions. Same, this print statement, CISC 131 DL, CISC 131 DLs, they are the same ones, print CISC 131 DLs twice. But first one was defined, constructed based upon early definition. Second one is defined based upon the new definition. Therefore, they are behaved differently. Accessing variable objects, we simply access variable fields very easily, right? Questions. What is the value to the key Peter in the object section? If the value 0, then assign points to the values. Okay, right now, CRS object is currently this, right? Print CRS object. Then this is a students, and title is Mobile, and teacher is Ethan. That is this CLS objects. So what is student's value to the Peter's value? What is the Peter's value? Peter's value is 0, right? If Peter's value is 0, then assign the new points to Peter. So what we need to do is we can say, so Peter's value is 0, right? So we can say if Peter's value is 0, then what we need to do is we need to assign new value by asking, you can say enter and also we need to, this user input value is the string, we need to convert that to integer. Okay, after that, we need to see print CLS objects. See if that is the revised. So because it's a 0, then we enter, let's say 87. Okay, so all others remain the same, but only Peter is newly defined, right? Because we enter the pointer to Peter accordingly, like this. That value, whatever that value evaluated on the right hand side, assigned to a left hand side. What is the left hand side? Left hand side is Peter's values, right? So that is 87 here. Insert the value to a dictionary students. So, for example, recall this, print that Peter, we know Peter, change grade to directly Peter's value. Okay. So Peter's value is like this. The others only single values, but we can say if we consider multiple, right? And if we want to add more, then we can say CLS object dot students Peter again, and then we can append. I can say 99. All right, and then print CLS that. See what happens. Okay. Peter's this is 77. Oh, because of this, there's no such values. So we simply say, originally 77, we appended a 99, so that we have this 99. Okay. We can do this in general way, which means if we have a multiple of those, so that we can see here, enter the grade for Adam, we can make a multiple of those continually. How can we do that, right? If I run this, then this all disappeared. But currently this, but as we added here above, right? So we can make it if we know dictionary dict. Okay, so a little bit of codings, for loops. So what should we do for that? So we can simply say for each in CLS object students, and then students object each, enter the points to the specific person, and then we can enter, say for Adams, what is the next number? Then we can say 77. What's the next number for Sam? Maybe 19. What's the next number for Peter? Say 67. What's the next number for Chris? Then 55. Then finally, we have this, right? We change that. How can you then, not only this, but can we add, this is a replacement, right? How can you add this over there? Then you need to do you need to save the current ones, right? So you can say current ones is CRS students each, so current value, right? This current value, I want to put this in a list, therefore we can add. Rather than replacement, we want to add. Okay, and then what we need to do is current CURL append. What do we append? We need to append something that we get from user. Okay, we append whatever we get from the user, and then finally that current value with something appended together assigned to that student's grade, I mean class. So when I do this, then in addition to this 99, let's say the first homework, this is the first homework number, and the second homework number, let's say 76 for Adam, second homework number for Sam, 54, second homework number for Peter, 67, second homework number for Chris, let's say 99. Then having this 99, whatever given, that's added to it. How it is possible? The current number, I made it in a list. See here. Therefore, I have here a list outside the square bracket. Because it is a list, then I can get the new value to append to it, to the list. And then altogether, I replace with that ones. Okay, it's a long lesson for today. The first thing that you hear about object-oriented programming is very, very confused. But don't be afraid of that. I mean, practice is needed. Now we need to think of the invoking methods, okay? And then we will stop. Currently, student 3 is Chris, major 32, score, course CIS 231. That was constructed here, student 1, student 2, student 3. Student 3 is an object for this construction result. Chris CIS 231. Okay. Add data, add more data. Then we need to do. We can use add. So s to the 3 dot add. Let's say CIS 132. Student 3. We need to think very carefully. This add, if it takes dictionary formats or whatever formats, may not be defined in a dictionary because it is now this, right? So we can simply add to a value only. It should be okay in this case, right? So if we do this, what is that? List cannot have no attributes updates. So we need to go back to the definition of student 3's class. Go back. student 3 is class. What is the current students? Go back to students here and add, oh, this guy needs update only, right? Which means if we have this instead update append, if we change this, let's put the update as is. Otherwise, we have to define this class, and then this instance needs to be reconstructed. That is more construction requires. We simply change this. That guys need currently. So this students, the problem here is the course. The course needs to be changed. So I need to do student 3 dot course, which is course, needs to be changed by CISC 231, and then whatever value A. We need to change that way. Then we can, because this update, the add is nothing but update in the definition of that function. So we need to do, that protocol needs to be made. So initially say no grade. So that is possible, right? So initially the course is only course number, but now it is changed. Therefore, if we see student 3, then it could be this 131, that. This is already updated, therefore it gives me twice. I think this much that we cover, and then we continue to do in the next week object-oriented programming, because we covered all already from the defining class and instantiation of objects based upon a class definition, and we tried to access field values and also invocation of the method that was defined in a class. So next week we'll continue to do that a little bit more. All right, I'll see you next week.